Find all of the unknown angles of triangle PQR. Give all measurements to one decimal place. Now, to find the first angle, you have only one option. There's no right angles. Well, I suppose you could check for right angles. You could check, well, is 4 squared plus 5 squared is 6 squared? No, it isn't. So once you've established there's no right angles, you've got a side triangle, as in you've got 3 sides and you need to find an angle. You've been asked to find 3 angles, but if you can find one angle, then suddenly you've got a lot of options. So you now only have one option, and it's the cosine rule. So basically you can find any of these really. So I probably just start with this one, it's closest. So we'll call that big A. Remember, A is always what you want, and the way I've remembered to label it, it's just kind of so automatically ingrained that I'm not going to go with the way the formula sheet has logged it, which makes C the subject. If you want to, it's not that big a shift, but I'm just not going to do it myself. So A is the subject, little a is opposite big A, and B and C are the other two. And just for a bit of a rearrangement, the formula book certainly doesn't give you it as cosine A or cosine C of the subject. So A squared equals B squared plus C squared minus 2BC cos big A. So if you want to make cos big A the subject, you need to add 2BC cos A on both sides and subtract the A squared. So that would be 2BC cos A equals B squared plus C squared minus A squared, which means that cos A equals B squared plus C squared minus A squared. You need to divide through by 2BC. So now we can work that out. So it is going to be 6 squared plus 5 squared minus 4 squared, 6 squared plus 5 squared minus 4 squared, all over 2BC. So 2 times 6 times 5. And that gives us an answer for cos A. So 6 squared plus 5 squared minus 4 squared all over 2 times 6 times 5. That gives us 3 over 4, quite a nice number. Cos A equals 3 over 4, which means that A must equal the inverse cos of that. Which, although it's quite friendly, it's not friendly enough so that we can't use a calculator. So we need to do shift cos ANS. And execute, that gives us 41.4096 degrees. You don't need to worry about an ambiguous case in cosine. There's no issue because once you get beyond 90 degrees, cosine of the angle is negative anyway. And once you get beyond 180 degrees, it's not possible in a triangle. So no ambiguous case to worry about with cosine. So I'm going to put this on the diagram. So 41.4. So now you could just do a similar approach and change the angle you're looking at, relabel it or think about it and just do the same thing again, which there is an argument for doing that because then you are using numbers that you've been given. But I suppose if you got it wrong the first time, you probably get it wrong the second time. So the other option is to follow through with the number. Then we have an option of using the sine rule once we have one angle. So I'm actually going to do that. So I'm going to say, well, these two are an opposite pair. So maybe the 6 will find this angle at R. So I can call that PRQ. So sine PRQ over the side opposite 6 equals sine of the angle we just worked out, so 41.4 and so on. over the side opposite to that is 4. So that must mean that sine PQR equals 6 times sine 41.4 dot 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 over 4. Okay, back to the calculator. Remember to use the long number for accuracy. So you could put 3 over 2, but I'll stick with the 6 over 4. That's 6 times sine. I'm going to use ANS. 6 times sine answer over 4. That gives us an answer to sine theta, very close to 1, so 0.9921. So PQR equals, what is the inverse sine of that? Back to your calculator, shift sine ANS equals shift sine ANS equals, that gives me an answer of 82.8192 degrees. So 82.8. So 82.8. That was this angle here, 82.8 degrees. So now, find the last one. We've got 3 angles. We can just use angles in a triangle. Add up to 180 degrees. So that angle is PQR, and it's going to be 180. Take away the 41.4, take away the 82.8. PQR equals 180 minus 41.4 minus 82.8. Try to use all the accuracies, so writing those long numbers down, now it's actually quite useful. I never use memory storage in calculators. I probably should learn to, but it's getting late. 180 minus, so you can just about see that number, but I did write it down anyway, so 41.4096 will do. 4096 minus, and the 81.8, I've still got that stored as the last answer, so ANS. So that gives us an answer of 55.77. So that's going to be 55.8. And I'm going to go and put it on my diagram. 55.8 degrees.